Hey, good afternoon. So today we'll talk about, we talked about UML the other day, which will help you with your P3 deliverable. And now we're going to talk about requirements and test cases, also to help with the P3 deliverable. And whoops, I guess I should do this. There we go. Okay, these notes are online. They were actually created for SC310 by Dr. Oshwa. And he's a real expert in software requirement specification. So I adapted these to CS225. When you take SC300 and the follow-on SC classes, you go through software requirement specification in much greater detail than we do here. This gives you an introduction to the topic and some basic rules for how you create requirements. So let's see, what is a requirement? Well, the requirement itself is actually something that the user needs. Now, you are the product, you are the customer basically for your own project, but it's basically something that the customer needs, the user of the product needs. Technically, what I'm asking you to do in P3 is to write a requirement specification. The specification is specifying what the requirement is in terms of functional behavior. But I'm going to use the terms interchangeably. Almost everybody says requirements when they're really talking about requirement specifications. You do sometimes have to be careful about what you're talking about. You normally get requirements from the customer. They come to you and say, we would like you to build some software, or we would like you to build this thing. We want you to engineer this thing. Oh, and it has to do this and this and this and this and this. And those are the requirements. And then the idea is you work with the customer and try to get a clear specification for each requirement. They are the yardstick by which success is measured. So we'll talk about this a fair amount. You want them to be as clear, as unambiguous, as testable, measurable as possible. You want them to be not cheatable. Because by the time you deliver your product, if your customer says, well, we'll take your product even though you didn't meet all your requirements, basically what they're saying is, we're not going to pay you. Hey, you didn't meet this requirement. Yes, I did. No, you didn't. Well, that's the sign of an ambiguous requirement. And yes, there will be some customers who will take advantage of the ambiguity. If they can save $1 million, they're going to take that path to save the money. So the goal here is to be as clear, unambiguous as possible, and it's a difficult goal because we're going to write these in English. We're going to write them in a natural language. Natural language is inherently ambiguous. Okay, so the requirement specification. A couple of things here. There's one missing that I want to. I should add. I'll just add it in here. It's not in the. Okay, so first of all, it describes the what and not the how. The design is the how. The design is how you meet that requirement. The requirement should not specify the design. Now, there may be some crossover cases where the user actually says, no, this has to happen because you push a button. This actually happens because you use a slider on the GUI. If so, if that's really what the customer wants, that becomes part of the requirement. But as a general rule, you want to specify the behavior without specifying how you achieve the behavior. And we'll see some examples that violate that in the examples that I put online. Shall be atomic. What do I mean by atomic? I mean, you can't break it apart. If the word and shows up in your requirement, it's probably not a good requirement because what you're probably saying is two things. It should be broken up into two requirements. The product shall do this and that. Okay, that's two requirements. The product shall do this. Separate requirement is the product shall do that. And I'm using the word shall. Requirements use the word shall. You will see that some authors differ on this, but this is the industry standard. Shall is the legalistic term that says If you don't meet this requirement, you have failed. The corollary to that is should. The product should do this. Some people use must. Must is equivalent to shall, but shall is the preferred terminology. Should is never any good. Yeah, it should, but it didn't, so what? I didn't fail the requirement. It should, but it didn't. Yeah. Whereas if it's shall and it doesn't, then you've definitely failed the requirement. The generalized format is fill in the blank here. The system shall do something within usually some time frame with the units specified, seconds, days, months, after something happens. Now, some of these can be left out, but that's the full format. The system, the software, this class, this method, the method shall. The calculate area method shall correctly calculate the area within, maybe we don't need that, after a radius for the circle has been set. The calculate method shall return the value of the area within 1/2 of a second after the radius has been set, or the request to calculate the area has been made. Things like that. So use that as your template. Use that as your boilerplate. That doesn't mean you have to fill in every single one of those bracketed fill in the blanks, but you may. A lot of these, if they're just talking about how that some method needs to do some kind of calculation correctly, may not have the time frame, but it might have another indicator. Maybe something is difficult to calculate. The calculate area shall compute the area within 1% after being requested to do so. By the way, compute the area is a vague term. It would have to be formally defined. You remember in your first homework, second homework, I was asking you to do these, get this volume of boxes, the surface area of boxes. And I specified very clearly what the formula for volume was, what the formula for surface area was. And I did that before I made the requirements. Sometimes I'll see students try to sneak definitions in the requirements, and don't do that. If you find that you're trying to sneak a definition in a requirement, put that definition up in the problem description. Or even in the requirements and test document if you need to, because there will be some text ahead of the requirements in the requirements and test document. And so you can put some definitions in there. Everything should be as formally and fully defined, unambiguously defined as possible. Different representations, we'll focus on the formal representations. And by formal, we mean use math. Use math if you can. If you can't use math, then you use the informal representation. You try to capture the behavior as fully and unambiguously as possible in English or whatever language you're working in. A bunch of different don'ts. Don't use superlatives, best and most. If you say this will be the best software ever, how do you measure that? You can't measure that. Things like user-friendly. The GUI shall be user-friendly. I see that a lot. The user shall be easy to use. Well, that's nice. How do you measure that? Where's the yardstick? Ambiguous things like almost always. The software shall almost always work. I have no idea what that means. These are far too fuzzy. Here's a good one. The loopholes. If possible. You know what? I don't think it's possible. The calculate area shall calculate the area if possible. Okay, I am not even going to write a calculate area method. It's not possible, and I'm just past that requirement. Think through how people might cheat your requirements. If you put in terms like if possible, you just gave them a huge loophole. Nope, not possible. I didn't have time. Negative statements. You can't prove a negative. The software shall not do. The software shall not. The software shall no. Turn it around to a positive. If it's something like the software shall not accept values larger than 100, that becomes the software shall default to 100 for values of 100, right? Explain the actual positive behavior. The software shall provide a warning if the value is greater than 100. For our calculate area for circles, the software shall not return a negative area. Oh, that's no good. How about the software shall return, or the calculate area method shall return a value of 0 if presented with a negative radius. And you can have a second requirement. The software, the calculate area method shall print a warning or shall provide a warning if presented with a radius of a negative value or less than 0. Each of these following slides has a slide for correct and complete and consistent and traceable, trace verifiable, unambiguous. So correct, every requirement that needs to be in there is, and if a requirement does not need to be in there, it is not included. You should only make requirements for things that are required. There's 2 reasons why you don't. You don't do extra work for free. Customer wants this, that's what you give them. Don't do extra work for free. Now there's a small exception to that. If along the way you can add in an extra piece of functionality that you know will delight your customer and they will come back and give you more money next year, you may choose to do that. It's your choice. But if you do, I wouldn't make it a requirement. What if you think, oh, we're going to add this extra thing and it won't take much time. Let's make that requirement. And then it turns out it's harder than you thought and you fail that requirement. Now you failed a requirement that was never was supposed to be there in the first place. So don't make it a requirement. Don't put yourself up on the hook for things that are not asked for by the customer. Now, if you wanted, again, please your customer so they come back next year with another contract, that's a different situation. But you don't have to make it a requirement. And watch for gold plating. Gold plating, also known as scope creep. So when the customer comes in, they want this, and then they're like halfway through the build, hey, I didn't know we could do that. What if we added that too? And your response should be, yeah, no problem. We'll make up some requirements and user stories for it, and we're going to ask you for another $50,000. That's an okay response. But just saying, yeah, we can do that, and adding it as a requirement, or having your customer try to force you to accept a requirement that really goes beyond the scope of the original project is gold plating and something to be watched out for. Scope creep is very common in software. Completeness, again, defines everything the software is supposed to do. Consistent, you can actually, when you start to make requirements, here I'm going to ask you in this class just to make 5. And the idea is to give you give you practice, give you some feel for creating requirements. And when you take SE300, you're going to make more. Your project will be in a team and you're going to make more requirements, and it would not be crazy to have 40, 50, 60 requirements. Once you start to get that many requirements, it turns out you may make inconsistent requirements. I can meet requirement 5, but the only way to meet it is to not meet requirement 12. So they all need to play together. And your terminology needs to be consistent. Traceable, this is a big one. We don't focus on it too much here, but this is a big one. The idea again is you only should have a requirement if it was needed. If it actually is something that's going to demonstrate that you're providing what the customer asked for. Now, you're your own customer here. which means your customer initially says, hey, we want some software that does this, that, and the other thing. And then you create a bunch of user stories for that. And then for each user story, you create some requirements. Why is that requirement there? Well, it's because of that user story. Oh, why is that user story there? Oh, because it addresses this customer need. So we can trace backwards to say where we got the requirement from. If anyone asks, why is that requirement there? We can trace backwards and say it has to be there to meet that user story. Oh, why is that user story there? It meets this customer need. But you can also trace forward. How do we know we met the requirement? Where in the code do we meet this requirement? So in a full software design document, you would specify in your design, this is where I meet this requirement. So now I can say, here's my requirement. Do I meet it? Yeah, here's where you meet it in the software. And then you go one step further. How did I verify that I meet it? Here's the test case or test cases. So you can trace backwards to find out why the requirement is there. You trace forwards to say, here's where we meet it and here's where we test it. This traceability goes all the way up and down the line. If I started out with the test case and said, why is this test case here? Oh, it's here because of this requirement. Why is this requirement here? It's here because of this user story. Why is this user story here? It's here because that was satisfying a customer need. Traceability becomes a big deal in terms of, once you have 100, 200 requirements, it's hard to manage, right? So you have to do a couple things. You have to trace backwards to make sure that all 200 requirements actually had to be there. And then you need to trace forward for completeness to make sure you actually met all 200 requirements. So traceability becomes a big topic in sophisticated software, production software. Verifiable. Oh, okay, verifiable. That means that you have to be able to verify it. Oh, so here's some examples. The system must be user-friendly. How do I verify that? The user interface shall be menu-driven. It shall provide dialog boxes, help screen, radio buttons, and drop-down list supports for user inputs. That's a tough one, right? I mean, okay, so even if I made that, I may not meet the intent of the requirement. I mean, what if it provides all these things but the user inputs are just crap, that it doesn't really meet the functionality of the system? That's really a non-functional design type issue. Now, again, if your customer is absolutely set on these things, then you can put these in your requirements. But rather than putting it in that way, you can be far more specific. This specific radio button performs this specific task. This specific drop-down list performs this specific task. You can break it up. The system shall usually generate an output within 10 seconds. Oh, nobody knows what usually is. Quantify it. The system shall generate an output within 10 seconds, 98% of the time. Oh, by the way, that's hard to test, but at least it's a clear requirement. The system shall generate output B within 10 seconds of event A occurring. That's probably pretty good as long as we know what it means for event A to occur. Does that mean the initiation of event A or the termination of event A? If these are networked machines, event A may complete and the other part of the system that has to do output B may not even know about that for half a second or 2 seconds. Well, heck, 2 seconds out of 10 seconds is a long time. So you have to still fully nail down these things. Basic top-level things to think of. How can I cheat? And do I believe that if I gave this requirement to 10 people, they would all have the same understanding of it? One way to convince yourself that that's true, and I'm going to have you guys do an exercise on this before you turn in your P3. One way I'm going to have this be tested is actually share your work with other people, have them look at it, have them tell you if they figured out a way to cheat your requirement. That's not being a jerk, that's improving the product, right? If you make a requirement and somebody can cheat it, wouldn't you want to know so you can change the requirement and improve it? Unambiguous. Now these are tough. So the systems try to use numbers and math as much as possible. The system shall respond to the user's request quickly. Clearly that's ambiguous. The system shall respond to user's request A within 2 seconds. Okay, that's better because we have a specific user request and we have a specific time frame. Not necessarily do we know what respond means though. Does that mean it begins the response or ends the response? And what is that response? The system shall respond to user's request A with result B within 2 seconds. Oh, that's even better, because the middle one says it shall respond to user's request A within 2 seconds. And what if the response is to do the wrong thing, or to do nothing, or to do a random thing? That's a response, right? Met the requirement. So respond to user's A request with result B. Oh, okay. Now you've got a better feel for what's supposed to happen. So I'm going through. If you have questions, by all means, ask away. Okay, system shall be completely reliable. This is clearly not testable. By the way, there's a whole field of engineering that has to do with reliability, and they've built up over decades, and I mean decades, all kinds of math models about what it means for something to be reliable. How do you measure it? How do you advertise it? What are the specifications that you have to put on the system in order to make these claims? So completely reliable, that doesn't really mean anything. Same with modular. It shall be modular. Well, it's object-oriented design. Must be modular. No, there's actually measurements for how modular your object-oriented design is. So you have to put these things in. Errors in the system shall be less than 99%. That's really weird because they actually made it where technically your system could be 99% composed of errors, and you've met that one. And they really meant they wanted the system to function correctly 99% of the time. Well, by the way, already there's some confusion of how do you measure that. Is it measured in hours or is it measured in user requests? Okay. The rest of these are much more clear. The system's response time for all level 1 actions shall be less than 100 milliseconds. And we're assuming there are other requirements that specify what those responses are. Cyclomatic complexity of each module in the system shall be within the range of 10 to 40. Cyclomatic complexity is a measure of modularity. 95% of the system transactions shall be processed in less than 1 second. As long as we've defined what the system transactions are, that's probably a good requirement. System's mean time before first failure shall be 100 hours of continuous operation. There's a whole field of mathematics dealing with the statistics of mean time between failures, time between events, time for 3 or 4 events to occur, things like that. It's called stochastic processes. Great course, by the way, if you find a place to take it. Okay. We're not doing a full software requirement specification. That can easily be a 60, 70 page document, more for commercial software. I'm asking you to do a requirements and test document, and I'm looking at a 3, 4, 5 page document. Right? Again, to give you the flavor of this, to give you the feel of it. And we'll talk about that with the template next week. Communication, why do we write these things? Puts everybody on the same page, gives you a measurable yardstick by which you can judge the success of your software and the completion. Remember, you're right, you wrote user stories last week, and then you're going to work on these user stories. How do you know when they're done? How do you know? And again, the idea behind a user story is when you're done with it, you are done with it. You never have to touch it again. So how do you know when you're done? Well, if you have a set of requirements for that user story and you passed all the tests, you're done. That's the official statement of what's is required. Again, that goes back to money. There's basically two types of requirements, the functional and non-functional. We are only going to focus on functional in this class. The non-functional tend to be things that are difficult to measure. Efficiency, maintainability. How are you going to measure maintainability of your code? Well, you're not going to do that because you're going to write your code and then you're not going to maintain it till after the semester. But you can do the functional requirements. Yeah. We can skip all this stuff. Just skip all this stuff. Okay, that's that. All right, so let's look at some requirements and test cases from previous semesters. Before we do that, do we have a question or 10? Okay. So this person was creating a music player, like an MP3 player. Let's look at their requirements. The program shall play the selected song, first song in list if none is selected, in the list when play button is pressed. What do you think of that requirement? Good, bad, average, pretty good, but needs some tightening, horrific? Where does it fall on the spectrum? How would you cheat it? Could you cheat that requirement? Get good at being sneaky. It cannot just select and play only the first song. Yeah, so there's the first thing. It's a little confusing because technically there's two requirements in this one requirement. The first one is if you have selected a song and press the play button, I'm saying play button, then it'll play that song. The second requirement is if nothing has been selected, then it plays the first song in the list. So that's two requirements. So that's first things first. That should be broken out. The next thing is when the play button is pressed, play the selected song. What if I made software that played it next week? Did I not meet that requirement? So maybe we should put a time frame in there within 1/2 second, something like that. Now, if you wanted to, you could put some verbiage and make things really loosey-goosey and say, I'm not even going to worry about time frame. If it happens, it happens. And deliberately get rid of that, because if you put it within 1/2 second, it does add difficulty to your test requirements, because not only do you have to make sure the correct song got played, you have to make sure that it, you have to put a timer in your test process to make sure it happened in that short period of time. If you were doing real live commercial software, you absolutely would have to do that. For a course like this, where you're just getting introduced to requirements and tests, explain what you're doing, explain why you're doing it, justify why you're not doing the time frame, and then maybe you can get away with it because you still have made it unambiguous. You've made it clear what your intent is. I do have a little problem with this. When the play button is pressed, that snuck up on you so quick you probably didn't even see it. We've all used MP3 players. We all know they have a play button and a pause button and a rewind button and a stop button. But that's a design element. What's really happening is you are requesting that the song be played. It's really a request or a command to play the song. How is that command going to work? The play button is pressed. Probably that's how it's going to work. But that's a design decision. Maybe you hit the space bar. Maybe you double click on something. Maybe you can double click on the song itself. If you have a graphic showing the song, maybe you double click on the song itself instead of pressing the play button. That's a design element. So it's more like if we go in the line of, okay, if we set up these preconditions, right? Describe the preconditions. When the user has selected a song and requested that song be played, the software shall play that song. Even that you can push into the weeds more. You know, maybe you've got an attribute called current song. Well, you can specify that. The attribute value shall be. Attribute for current song value shall be. And then a separate one would be if the user has not selected a song and has requested play, then the first song in the list will be played. Separate requirement. The program shall pause the current song when the pause button is pressed. Again, maybe what it does is it plays the rest of the song and then pauses. That meets that requirement. Right? It meets the literal text of the requirement. It does not meet your common sense definition. And that's the problem. We're so used to dealing with common sense language that we don't think about how it can be perverted. And you need to get good at thinking about that. You need to get good at thinking about how you could cheat the system. You didn't tell me when it's going to get paused, so I'm just going to wait till it's the end, and then it pauses magically. Met the requirement. By the way, when you get really good at this, you really have a hard time. You know, if you don't have the ability to turn this ability on and off, it's hard to listen to just people speak in everyday life, right? Because they say crazy things. What do you want for dinner? Anything you like. Right? Sit anywhere you want. Okay, I'll sit on the dog. Right? We assume people will behave reasonably. You can't make that assumption here. How about this one? The program shall shuffle songs in current list when shuffle button is pressed by rearranging the songs in the list. First of all, how would you cheat that? Let's say you actually respond instantaneously. Your software responds instantaneously. How would you cheat that? Here's the key. We're going to rearrange the songs in the list. So here's my songs. The first one is titled A, and the second one is titled B, and the third one is titled C. I've got 26 songs, A through Z. And when you hit the shuffle button, all I'm going to do is swap out the A and the B. So instead of A, B, C, D, E, F, G, it's B, A, C, D, E, F, G on down through. Technically, have I not met that requirement? I rearranged the songs in the list. The problem is, again, we all have had CD players or MP3 players where we could shuffle songs, and so we know what that means intuitively or in a natural language everyday statement, but it hasn't been defined.
Something random.
Exactly. It's got, the idea really is that if you hit the shuffle, you know, if you input the shuffle command, right? Don't say hit the shuffle button, but you input the shuffle command. What you really want is for every song to have an equal likelihood of ending up in any particular place in the list. Now, how the heck are you going to test that? And that's a hard test. That's a hard test. That would actually be better. That requires some, we don't talk about it much in this class. You can meet some requirements through analysis, and that might be a better thing to show by analysis, but then you still might have to do tests. And the proper test for that, by the way, is to shuffle a list 10,000 times, keep track of where every song ended up, and show that for every song you basically have, within statistical error, you have an even distribution of that song across all 26 slots in my example. So shuffle has not been defined. There was a kind of an abortive attempt to try to define it here. But what did I say? Don't put your definitions in the requirements. You need to define in a very clear way what shuffle is before you can use it in the requirement. Program shall skip to the next song in list. When skip button is pressed, there's that button again. Program shall display the songs in the current list. That's good because it didn't talk about how the display occurs. So these aren't like, oh my God, the worst requirements I've ever seen, but you can see that if you start to think about how can I pull a dirty trick on this person, how can I cheat, they're quite cheatable. How do you make them less cheatable? It's difficult. Oh, and by the way, it's difficult. It's difficult in this class. It's going to be difficult in SE300. It's going to be difficult in Capstone. If you get a job doing software, it's going to be difficult there too. It's not, unfortunately, I can't give you a magical formula to make it all easy. That format that Dr. Ochoa showed you is good though. It helps you clarify your thinking. Look at the requirements that Dean has put into the homework assignments and that I put into the homework assignments. Now, if you find that they're cheatable, let us know. I'm not saying that my requirements are the best ever or the best possible. I think they are acceptable. But if someone has a better way to write them, I'm happy to improve the product. And that's really what it's about. It's about improving the product. Okay. Exactly. That's one of the things is you know that's what the like beta testing is all about, is people, you give it to people who are not involved in the production of the software, and they will do things that you never thought of. In terms of requirements, the requirement equivalent of that is to give your requirements to other people and have them comment back. Have them tell you what they think it means, and have them tell you if they can figure out a way to cheat it. And then you have to decide if it's worth trying to play. Now, test cases. Requirements should be specific. Test cases are even more specific. So here's a test case. Left click pause button. Expected behavior pace. Play song. I don't know if that's right. I think he means play button, but I could be wrong. Left click pause button while song is currently playing. Pause song, pause song. There you go. Left click, I think this is left click play button. Play song, play song. Okay, so the expected behavior is to play the song, is to play song. So, is this a good test case? Are there issues with this test case? Let me ask you a question. What song got played? We don't know, right? Oh, okay. Here's how you know if you've got a good test case. You imagine this thought experiment. You give your test cases to 100 different people, and all 100 literally did the exact same thing. In other words, all 100 would play the exact same song. Well, we haven't specified a song, so hard to fail that test. The input needs to be something along the lines of, and you can, by the way, you can do this up ahead of the table here. You can say, here are my preconditions for my test. User has started the program. User has selected pre-formed list number 1, right? So we know exactly what songs are in there. User has selected Rhapsody in Blue. Now, left click play button. Expected behavior, Rhapsody in Blue plays. The framing here is all about user actions, by the way. Left click, right click, left click. These are user actions. It's hard to capture the behaviors when you're doing that. I would recommend that you do not do it at the user action level. When the user left clicks the play button, what's really happening? a command was sent from some class to another to activate the play song method. Why not write the test case that way? Play song method activated with input Rhapsody in blue, expected behavior Rhapsody in blue. Now that's something, instead of having to create your entire project so that you get to the point where you can do user input, you can write a method that sets the attribute and then calls the play song method. Right? You can write software to do that testing. Again, you're creating the software. You can change any attribute value you want. In the name of testing, you probably should. So this passed, yes, it passed. I don't know, maybe it passed, maybe it didn't, right? The fact that it could play any song makes it hard to fail. Left click, shuffle button, swaps positions of songs in the current list. Again, you really need expected behavior is tough to do there. And that's because probably the test case is actually should be, you have to do this 10,000 times and do an analysis, expected behavior for all songs in the list. Equal distribution of songs in the slots. By the way, for some reason, I think that didn't pass. Swap positions of songs in the list, no change. Yep, passed. Okay. I guess technically it passed because no change is technically a change, right? If the empty set is a set, if the empty string is a string, well, no change is a change. Okay. By the way, if you don't pass a test, that's exactly the right thing to report. No, I did not pass the test. That's exactly the right way to go. You don't just try to claim everything passed. I've had students, it was clear their code wasn't complete. It was clear their code could never compile, and I couldn't get it to compile, and yet they're claiming they passed all their tests. And I'm thinking, yeah, that probably didn't happen. Yeah. Here's some that are a little. By the way, you have these examples online. We have some movement algorithm. We've got the UML diagram, test cases and results. Let's see. So look at these. So here's a requirement. Simulation shall terminate when total healthy people reaches 0. Well, that's probably a good requirement. Maybe you could say terminate within 0.1 seconds, but that's probably pretty good. And then we say run program as normal, wait until healthy people equals 0, and then the expected behavior is the simulation terminates. Do you like that test case? Run the program and wait until the healthy people equals 0. Let me ask it a different way. If all, I think there's 6 of you online, if all 6 of you ran the program, you can begin, the way you begin this program is you tell the program how many healthy people you want, how many unarmed healthy people you want, how many unarmed healthy people you want, and how many zombies you want. Would all 3 of you, all 6 of you, start the program with exactly the same number of unarmed healthy, armed healthy, and zombies? What's the likelihood of that all 3 of you would run exactly the same test case? Pretty low, right? So that's the question you want to ask. If I gave these tests to different people to run, and quite frankly, in the real world, that often happens. You give it to a test engineer. I give it to a different person to run. Will they do what I thought? And what's really going on here, run the program again from a user standpoint, but you don't have to restrict yourself to a user standpoint. What's really happening? When the number of healthy people equals 0, then the simulation terminates. Why not just have a test case where you literally set the attribute value for the healthy people to 0? That's a pretty clear test case, right? Set the attribute to 0, forget the user. You can do that in code. You can do that as a test case in your code. Set the attribute to 0 and simulation terminates. And probably what you really want there is there's a method that keeps looping and looping and looping to run the simulation, and that method quits. That method returns void or whatever. Maybe you even print out simulation terminates. Now you've got a pretty clear thing. And if everybody was told, hey, you've got to set in this class, you set this attribute equal to 0, there's your test. Now these are better because the person is actually setting these simulation up for you. So now if I said, what's the likelihood of all of you would do this test using one unarmed person, 0 armed people, and 3 zombies? And the answer is pretty good because that's what the thing told you to do. And I still have a little bit of trouble here because there's an assumption that the zombies will win, and maybe that's not true. Maybe the unarmed person finds a way to defeat these zombies. Maybe the unarmed person, there is weaponry that can be picked up in this game. Maybe the unarmed person finds some weaponry. And similarly here, 1 armed person, 5 zombies. And this is tough. Expected behavior, simulation terminates once armed people are zombies. They're really putting the conditions over here in the expected behavior. If the simulation should terminate once the zombies equal 0, that's your test case. Set that attribute to 0. So we can do that for all of these different test cases. But the point is your test cases should be exactly this specific. Input 1, input 0, right? Input real numbers. I've had students that had like a username password on their projects. And the first test cases is put in a good username password. No, that's not a test. Put in test user, literally that phrase, and test password, literally that phrase. That's a test case. If your system is supposed to do something when x is greater than 0, then you don't say input x greater than 0. You say put in x is 1, a literal thing. And if you're getting away from this user input, then what you do is you set up all the conditions. Start the program, set this attribute to this, set that attribute to that, set that attribute to that, fire off this method, and here's the result I should see. And you can do that all in code. Right. This could have all been done in a test code where they set the attribute for armed people to 1 and unarmed people to 1. And then the total people, I think there's a typo there. Total people should be equal to 2, right? The calculate total number of people method should return 2, or the total number of people attribute should be 2. No, not should be, shall be, right? Okay. Okay, we're out of time. Think through this. We'll go through this more on next week. And like I said, I'll set up an exercise where I'm going to divide you folks into groups before you turn in your P3, so you can have a small group of the class reviewing your documents with the point of, again, improving the product. You have to learn to be very skeptical and almost a jerk about it. But the whole goal, remember, is not to just try to gig somebody. It's about improving the product. All right. See ya.